In this video, we are going to discuss about wireless standards and networks. The course name is Mobile Communication and Networks, and the module name is Wireless Standard Networks. First, in this video, we are going to discuss about millimeter wave communication. Okay, what is millimeter wave communication? It is a kind of wireless communication technology that uses high frequency electromagnetic waves which should be in the range of 30 to 300 gigahertz. So in case of 30 to 300 gigahertz, this millimeter wave communication comes into a picture. So millimeter wave communication in mobile phones, it can be used with 5G mobile phones, which generally refers to 24 to 100 gigahertz, a frequency that can carry an incredible amount of data, and when coupled with the advancements in coding techniques can carry thousands of times as much as low band signal. Millimeter wave communication refers to the transmission of electromagnetic waves, as we have seen already. So the advancements in millimeter wave communication have led to significant breakthroughs in wireless technology, particularly within the context of 5G networks. Millimeter wave frequencies offer higher data rates and bandwidth capabilities, making them instrumental in enabling ultra-fast and high-capacity wireless communication. And then modulation techniques. There are a lot of modulation techniques which will be used for proper message transmission and reception. Modulation techniques are methods used to encode information onto a carrier wave for transmission, broadly categorized into analog and digital modulation, including techniques like AM, that is amplitude modulation, frequency modulation, and phase modulation. We also have orthogonal frequency division multiplexing, that is OFDM, quadrature amplitude modulation, that is QAM, single carrier frequency division multiple access, that is SC FDMA, and it has an advantages of as high bandwidth, that is it supports a faster data rates and low latency, which provides near instantaneous communication, and also antenna advantages, which allows for smaller antenna sizes. Then MIMO capability. MIMO is nothing but multiple input and multiple output, which enhances the spectral efficiency. Immunity to interference is less when compared to other communications. There is an enhanced security, which is difficult for eavesdropping due to narrow beam. Then going to wave characteristics. Wave is a general term for electromagnetic waves within the frequency between 30 to 300 gigahertz, which we have seen already. And then it has the properties of high frequency, short wavelength, narrow beam, and good directivity. So wave communication suffer from huge propagation loss due to higher frequency. The rain attenuation atmospheric absorption characteristics of wave propagation limit the range of wave communication. Besides wave communication, it is sensitive to blockage of obstacles such as human and furniture due to weak diffraction ability. Look at the first picture. There is an obstacle for a mobile phone communication in the form of buildings. So it is a blockage due to buildings. In the second picture, there is a blockage due to people interference. And in the third image, we have a hand blocking obstacle. Next one, higher data rates. Advancements in millimeter wave communication have unlocked the potential for significantly higher data rates compared to traditional wireless technologies. By leveraging the vast spectrum available at millimeter wave frequencies, researchers have achieved data rates exceeding multiple gigabits per second, paving the way for ultra-fast wireless connectivity. These higher data rates are essential for supporting bandwidth-intensive applications such as high definition video streaming, that is HD videos, virtual reality and augmented reality, enabling immersive experiences and real-time interactions over wireless communication. Then coming to the beamforming technology. Beamforming technology is a signal processing technique that focuses mainly on wireless signals to a specific direction. It is used in many technology including Wi-Fi, radar and sonar. Let me explain how does it works. Beamforming uses multiple antennas to send out multiple signals at a time. The phase and amplitude of each antenna signal is adjusted to concentrate the transmitted signal into a beam. This technique improves the signal to noise ratio, that is SNR ratio, and reduces the interference. And the applications of beamforming technology is Wi-Fi. It could be used in Wi-Fi, radar, sonar, speech processing, medical imaging and surveillance. When coming to beamforming in 5G technology, it is used to improve throughput and connection density. It works with massive MIMO, that is massive multiple input, multiple output, to increase signal range, minimize the interference. One of the key advancements in millimeter communication is the utilization of beamforming technology to enhance signal strength and coverage. It enables the precise focusing of a signal transmissions in specific directions by improving the reliability and efficiency of the wireless communication. Through adaptive beamform techniques, millimeter wave communication systems can dynamically adjust antennas arrays to optimize signal propagation, mitigate interference and extend coverage range, ensuring robust and consistent wireless connectivity in diverse environments. Next, antenna design for beamforming technology. It plays a critical role in overcoming the challenges of propagation and penetration associated with multimeter wave frequencies. And then these antennas feature multiple radiating elements that can be individually controlled to steer beams and adapt to changing propagation conditions. By leveraging beamforming and spatial multiplexing techniques, phased arrays antennas enable efficient communication with multiple devices simultaneously. So it is one of the most important advantages of beamforming technology. So it can maximize the spectral efficiency and also enhance the network capacity. Then small cell deployment. Small cell deployments in mmWave are used to increase the network coverage and capacity in mainly in urban areas. Small cells are miniature-based stations that use 5G technology to support mmWave frequencies. Small cell can help to fill coverage gaps in areas where macro cells are unable to support the mmWave. So small cells are essential for providing consistent experiences for subscribers. Small cells also often deployed on street poles. It can also be combined with lightning poles to conceal electronics, power and connectivity. It can also deployed in indoors and outdoors. It can operate in different frequency bands also. Because it has reuse techniques in spectrum. So often deployment of dense networks of small cells to overcome the limited propagation characteristics of higher frequencies. Small cell enable the efficient reuse of spectrum, enhance network capacity. So there is a lot of advantage when small cell deployment is deployed. And then another one example is massive MIMO. As we have already discussed, MIMO is multiple input and multiple output. It is a wireless communication technology that uses multiple antennas at both the transmitter and receiver to improve data transmission speed and reliability by creating multiple data streams over the same frequency channel. So, it do have a multiple number of antennas to provide a proper reliable communication. So, multiple antennas at both the transmitter and receiver ends. So, it works instead of transmitting data through a single antenna, MIMO splits the data into a multiple streams and transmit them simultaneously through the multiple antennas. So, if there is a multiple antennas, there is a multiple signals could be transmitted over a multiple antennas. So, it has a benefits of increased data rate, that is by transmitting multiple streams, MIMO can significantly increase the overall data rate and it has improved signal reliability. The use of multiple antennas helps to mitigate the effects of signal fading interference and leading to more reliable connection. And it also has higher capacity because it can improve, MIMO can improve the overall capacity of wireless network because it is allowing to handle more users and sufficiently handling the data traffic. For example, MIMO we can take Wi-Fi as an example and 5G networks, and we also can take satellite communication and wireless sensor networks as an example of MIMO. By leveraging advanced signal processing algorithms and beamforming techniques, massive MIMO systems optimize spatial resource allocation and mitigate interference, delivering enhanced power and scalability for next generation wireless networks. When coming to regulatory developments, the efforts to allocate additional spectrum and streamline regulatory process have accelerated the deployment in millimeter wave communication. Spectrum auctions, for policy initiatives, collaboration between government agencies and industry stakeholders have paved the way for commercialization of millimeter wave technology, fostering innovation and driving economic growth in the telecommunications sections. Now we are at the conclusion part. These topics illustrate the multifaceted advancements in multimeter wave communication and their transformative impact on wireless technology, underscoring the importance of ongoing research and development efforts in this rapidly evolving field. Keep learning and growing. Thanks for watching. Thank you.